So now we're going to take it up one more notch, and I'm going to introduce Boolean operators. Boolean operators are not the same as a Boolean data type. Boolean operators are and, or, and not. We use those words to make more complex statements. Okay? So somebody give me a number for x that would make this statement true. So any number between 2 and 10, right? So 9.000001 would be still okay. Okay? What number would make this true? What's that? 11 is actually one of the few values that would not be true because it's an or. Okay? So it has to be either greater than 12 or less than 10. So 11 is the only one that is both less than 12 and greater than 10. And it gets weirder because you can also combine ands and ors to make a really complicated, messy soup of Boolean logic that will confuse just about anybody. Okay, not would only be true if this is not equal to 5. What's another way to express that in a more simple terms? Right, it's exactly the same. Okay, it's exactly the same. Are there reasons to use one over the other? Sure. I'm not going to go over each case, but there might be a reason for you to use not, depending on how you introduce those values. It might be more logical or just easier to read. Okay. So give me a value that would return true here. 11, right? Because it's the opposite. So it just takes this, and if we put not, it just inverts it. So whatever was true before is now false. So playing with comparison operators is subject to math, a similar order of operations. So if I want to say if x equals 2, or, oops, that was assignment operator. Everybody does it sometimes. Y equals 7 and z equals 9. Okay, so will this print anything when I run it? Look at it carefully. Okay, so what I'm saying here with my complex Boolean is if either x is equal to 2 or both y equals 7 and z equals 2, so if this or this is true, then print. X equals 2, therefore it prints. Now, if I do this, will it print? Yes, because one of the two OR conditions is satisfied. So you look at the parentheses. So if this evaluates to true, then it's going to, because it's either this or this. Will this print now? It will, because because true is always true. Seems kind of like intuitive or non-intuitive maybe, but true is always true. So if anytime I put a true, the actual Boolean value of true in a statement, then it evaluates to true, and therefore it goes. So if I want it to do it every time, I would do this. Now, why would I have an if statement there? I wouldn't. But if I wanted to test just this block of code without having to worry about what was going on in here, if I had a more complex program, I could just change it to true, test the code, and test this block and see how it goes. Make sure I didn't have any errors there. It's a way of isolating pieces of code that you can do things with. And there will be an instance later on, actually next week, where we will use this value to instantiate a loop, but we won't be doing that yet. So when we talk about that do you like me note, it could be expressed in Python like this. If Boolean do you like me is true, then print yes, else print no. So now we can say, if we have something that's true, do this, but if it's not, do something else. So we started out is, if this is true, do this, and then move on. Now we have another option. It's an either or situation. We can also do something like this, where we say, if something is true, then write this is true. Or if something else is true, write this is true. Otherwise, do this. Let's take a look at that in code, because I know it's a little abstract to start with. Let's play around with these values here still. So we've got if x equals 2, then print elif. Let's just do else to start with, then we'll go more complicated. Else print okay, so this is our relatively simple starting place. If x equals 2, then print x equals 2. Otherwise, print x is something else. So when I run this, x is equal to 2, so it's going to print x is equal to 2. If I change it, if I change the value of x up here to 3, and I run it again, it writes x is something else. Now I can change this again by adding an elif, E-L-I-F, which is short for else if, and elif requires a comparison statement there, and it also requires, notice, if I have this indentation and I don't have any indented code underneath it, it's going to give me an error here. Python does not like it when you have a branching statement with no code block beneath it. Yes?
Why is it that sometimes you put spaces before and after the
It's completely random. Yeah, sorry for the confusion, but yeah, that's completely random. It doesn't matter. Sometimes just visually I put that in there, and sometimes I don't.
But it matters otherwise, right? When it's just one exclamation point matters? Or not? Sorry,
One equal? No, it doesn't actually. Yeah, you're not required to. Notice though that also you don't have to put parentheses there. I always do because it helps me see where my statement is. PyCharm says they're redundant. I say they're not. I say they're useful for the coder, but you are welcome to do either. Print. So if x is equal to 3, I'm going to write x equals 3. And if it's not equal to either of those, it's going to write x as something else. And I could have as many elif statements as I wanted to. I could do one for every number between here and 100. Okay? Where I have it do something else. So I can have as many elifs as possible. You can have only one if and one else per group, but you can have as many elifs as you want. Okay, as many as you want. So if I run this, x is equal to 3, so it's going to say x equals 3. And then again, if I change x to 4 and I run it again, it'll say x is something else. So now, let me make something very clear that, oh yeah, question?
Just some, like with the equal to, or sorry, the greater than, less than sign.
Uh-huh.
Is there any way to use those with the beginning integers to make like the elifs just less redundant?
You could, yeah, you could say if x is greater than 2 and less than 100, then print x equals whatever x is. You could do that, yeah. Mm-hmm. Yeah, but let's say this was a menu where you press 1, 2, 3, 4, and then you have it execute different code. Then you would need the elifs because it's more complex. This is just a simplified example. But yeah, you could do that here for sure. What we need to make sure that we're doing here is when we have an if and an elif, those conditions should be mutually exclusive, meaning there should be no way that both could be true. Otherwise, you're going to have unpredictable code things happening. So, for example, if I have in here y equals 7, now on a face value, that seems like something that you would logically want to do, right? Because y could equal 7 and x could equal 2. But if they're both true, you will never get to this line. And the reason for that is that if you have an if branch and I run this, it's going to say x equals 2. The reason for that is that in this branching structure that I have here, as soon as Python encounters something that's true, it exits this. It does this block of code, and then it skips down to the next line that's not indented. So when you have two things that could be true, it's going to give you really confusing results. If I wanted to test whether x could equal 2 and if y could equal 7, then I would have to structure it using three separate if blocks. If x equals 2 and y equals 7. Okay, so now I know what's going on. And if I run this, now it gives me the response I was looking for, which is x equals 2, y equals 7, both are true. And then if I change one of these, let's say I change x to 7, then it just prints y equals 7. Okay, so this logic is going to be tricky at first. If you're new to coding, building out these logical sequences is going to be tricky. So don't get frustrated with yourself. Give yourself a little bit of grace here and just realize that it's not an easy thing to learn, and it's a skill that you have to practice.